I'm here to talk about the meaning of the maximum modulus theorem. That says if you have a holomorphic function f that's non-constant on a region G, then f cannot achieve a relative maximum on G. And let me give you, this is a little weird, let me give you a calculus analog. So basically, if I have some sort of open interval, AB, and I have some sort of function f, what this function would say, if it were true in calculus, which it isn't, is that as long as you're differentiable and non-constant on region G, in our case our G is equal to the interval AB, the function can contain a relative maximum on G. In other words, you couldn't have the graph of a function look like this, because this would be a relative maximum. This is a little weird, right? I mean, we're saying that this is impossible. Something like this is impossible and complex. So what does happen? Well, let me show you a picture courtesy of Wikipedia. Right, so this is roughly what happens. Right? You get things that look like saddle points over regions. So at any point in here, there's always a point bigger nearby. Even right here, there are points bigger to the left and the right. There's no way to achieve a maximum. So the way of typically formulating this, this is on a region G. Regions have to be open. What this says is if you want to find the biggest point, and you can actually include the boundary, because the function just kind of extends continuously to the boundary of the open region. If you have a closed region where everything makes sense, the biggest point has to lie along the boundary, which looks like it's right about there. So thank you, Wikipedia. Thank you for your Creative Commons license, Wikipedia Commons license that allowed me to use this. So this is what's happening, and it's weird. So just something about holomorphic functions causes them to curl up like that and not just kind of give you a straightforward thing that looks like that. Looks like a little, you can't have a little hill in a holomorphic function. And once we have that, we can get the minimum modulus theorem. Which says, so there's no relative min unless there exists an A belonging to the region with f of A equals 0. Okay, so now let me first point out the difference between maximum moduli and minimum moduli. Right? There's no maximum modulus. Modulus is the distance from 0, so you can go as far away from the origin as you like. There is a minimum modulus, and so you can achieve this minimum modulus, and if you have a point where f of A equals 0, it will have a modulus equal to 0, and there's no smaller modulus anywhere. So we get that the modulus here is equal to 0, and that's got to be the minimum. So we don't have anything quite as strong as the maximum modulus, but it's almost as strong. It says there are two cases. Either you have a 0 there, or you can't have a relative min. Why couldn't you have a relative min? Well, if f of z is never equal to 0 on G, then 1 over f of z is holomorphic. So what we can do is we can apply the maximum modulus theorem to this, and it says, hey, there's no maximum to 1 over f of z. Well, if there's no maximum to 1 over f of z, then there can't be a minimum for f of z, since no f of z is equal to 0. So that's basically what it means. And so the key thing here is if you want to find the maximum possible value, you want to look at the boundaries if you are allowed to look at the boundaries. So it's kind of weird, but it's kind of cool. Thanks.